Let's go ahead and take a look at graphing a piecewise defined function. This function is going to be coming to us in two pieces. We have f of x equals 3x if we're looking at x values that are not equal to 0. And our second piece, we have f of x is equal to 4 if we're working with an x value of 0. So let's go ahead and start graphing this. I'm actually going to start with the second piece. If we have an x value of 0, our f of x value is 4. Which is the same thing as saying our y value is 4. So we have the point 0, 4. Let's go ahead and plot that on our graph. And now let's go ahead and work with the other piece. We're going to be working with the function f of x is equal to 3x, and we're allowed to use any x value except for 0. So let's go ahead and pick a couple x values to work with, and then we'll graph this portion. So I'm going to go ahead and build myself a little table. And if we pick an x value of -1, we can go ahead and plug this into our function, right? F of -1 is going to be the same thing as doing 3 times -1, which is going to give us -3. So as a point, I can go ahead and plot a set of ordered pair here. I have the point -1, -3. Let's go ahead and pick an x value of +1. We're going to get f of 1. This is going to be 3 times 1, or a +3. So I have the point 1, 3 on my graph. And if I pick an x value of 2, we've got f of 2, which is the same thing as 3 times 2, or 6. And so we've got the point 2, 6 on our graph as well. Let's go ahead and connect these points. Right, so I've got my line y equals 3x. This graph is going to be going on forever in both directions. Keep in mind I'm not allowed to have an x value of 0 here, so on this line, that origin point is an open circle. Let's take a look at some additional questions using this graph. This is the same graph. I went ahead and cleaned it up using Desmos just a little bit. So let's take a look at answering some additional questions. We want to go ahead and find the domain of this graph, how far left and right our graph goes. Keep in mind we have arrows on both ends of our line here. So our smallest x value is going to be -infinity. And it's going to go all the way until we get to 0, where we have this open dot here at the origin. Now, I don't want to stop my interval right here because I actually have a point that's defined up here at the point 0, 4. So I'm accounting for that x value of 0. And then my graph is actually going to pick up and continue going all the way to the right, all the way to +infinity. So this is one way that we could go ahead and write our domain, right? Everything from -infinity to +infinity is accounted for. Let's go ahead and take a look at our intercepts. Let's do our y-intercept first. Right, we have the point 0, 4. is our y-intercept. And if we want to account for our x-intercepts, we want to know where our graph is either going to touch or cross our x-axis. Notice that the graph actually crosses there at the point 0, 0. This would be one of your x-intercepts. However, it's not defined at this point. Right, we have an open circle on our graph. Let's go and take a look at our range, how far up and down our graph goes. Okay. Our smallest y value goes all the way down to -infinity. And it's going to come all the way up until it hits a y value of 0. Right, that's where this open circle is on our graph. And we don't have any other spots where we have a y value of 0 defined, so we're going to have to put a parenthesis on that 0, and then it's going to pick up again at 0 and go all the way to positive infinity. And our last question is asking us if this function is continuous on its domain. The other way to take a look at this question is ask yourself, if you placed your finger on your graph and you traced the graph, could you trace the whole thing without picking your finger up? Right? If I place my finger here on this bottom portion of my graph and I start to trace it going in this direction, I'm good until I get to this point here, the origin, where I have a gap. Right, that point is not defined. I'm going to have to pick my finger up so that I can go plot this point. And then I'll have to pick my finger up again so that I can come back to my graph and continue going up the graph itself. So the answer here is no, it is not continuous on its domain. Okay, it has a gap. At x equals 0. The other way we could say this is that it is discontinuous. At x equals 0.